AJAX is a technology that combines open, standards-based technologies to solve various problems with developing web applications. It makes use of asynchronous client-side calls to a server, as well as JavaScript, and data to update only a portion of a web page, without regenerating the entire page or blocking other user actions. Because the browser doesn't have to repaint the entire page, no flash occurs, and the server doesn't have the overhead and resulting delay of creating a complex page from scratch. This works quite a bit differently from ASP.NET caching, which always operates as part of the full page postback, although all or a portion of the page may not have to be regenerated on the server. By the way, you may see AJAX written as both all uppercase AJAX and propercase AJAX. According to Jesse James Garrett, who's the person who first formulated the technology and named it, the name AJAX is not an acronym. You'll also see claims that it stands for Asynchronous JavaScript and XML. But again, Garrett claims that it's not an acronym. And we'll accept that claim and let others debate the issue. Microsoft originally named their AJAX ASP.NET add-on Microsoft ASP.NET AJAX with AJAX all uppercase, and you'll still see them use that uppercase notation. But since then, they've now standardized on a propercase AJAX, and that's generally what we'll use throughout this course, unless I'm referring to some specific element that has it all uppercase. All right, I'm glad to get that out of the way. Now, a major goal of Microsoft ASP.NET AJAX is to make communication with the server as easy and fast as possible. So the framework does a lot of automation on your behalf. All of these automated tasks use a core set of browser-based, client-side technologies. And what we're going to do now is learn about the basic technologies that the AJAX framework uses. This understanding will help as you progress and learn AJAX in the various ways that you can use it within your websites. The most important object in all of AJAX programming, whether you're using Microsoft's framework or any other, is the XML HTTP request object. XML HTTP request enables communications between the client browser and the content server while the page is idle. JavaScript within the client performs the calls that go to the server and are then returned to the XML HTTP request object. This is important to remember because some users disable JavaScript, either accidentally or perhaps because of a corporate or agency-enforced regulation. Keep this in mind if you find that your JavaScript-based pages are not working. Confirm that JavaScript is in fact enabled on the browser for any pages that are failing. Now, XML HTTP request is a common object across all major browsers. But Microsoft first introduced this object in Internet Explorer 5, back around the year 2000. And it's since become part of the World Wide Web Consortium's standards, and is available in most modern browsers on all platforms. Each browser, though, has a slightly different name for the actual object, which is a little bit of a cross-browser bit of a pain. Internet Explorer used to use an ActiveX object named msxml2.xml_http. But Firefox, Safari, and other browsers use XML HTTP request. And fortunately, Internet Explorer now supports that same name. But you'll see this object often referred to as XHR. And that's just referring to that object across all browsers. All right, so let's take a look at how you can use this object within a client-side HTML page. What I'm going to do here is use a couple of HTML pages that use JavaScript and the XHR object in order to retrieve data from the web server without regenerating the entire page. So what I've done is I've loaded up Visual Studio 2010 and created a new web application, and have created two generic HTML pages, StatelistHTM and Core AJAX HTM. StatelistHTM is going to function as a source of data, a list of states. So I'm going to get rid of all the standard content here. Because this isn't a full page, I don't need the doc type, I don't need the opening HTML tags, and so forth. And I'm just going to create an unordered list and populate it with some states. Alaska and Arizona and California. A couple more. Texas. New York. And one more. Florida. And I'll save it. All right, so the idea is that from the main page, which is going to be core ajax.htm, I'm going to make a JavaScript call that is going to retrieve this information. And there's nothing magical about it being within an HTML page. It could be JSON data. It could be some sort of dynamic method that I'm calling and so forth. But this keeps the example fairly simple. All right, I'll go over to the core AJAX. So this is now going to be the main web page of the application. So the first thing I'll do is put some things in the body here. I want an input button. So I'll create a type button. And I'll give it a value so it says on the face of the button, get locations. And I want to implement an onClick method. This is going to call a client-side JavaScript function that's going to get that list of locations, that list of states. So I'll add onClick, and I'll call that getLocations. This method doesn't yet exist, but we'll create it in just a moment. And the other thing I want to do is provide a place where the page can place that information. So I'll include a div tag, and I'll call it locations. All right, so that's the main body of the page. And I'll go ahead and save it, save early and save often. And now what we need to do is add the client-side JavaScript that will make the call to the server in order to retrieve that information. So I'll go up to the head area here, and I'll add a script tag. And it's going to be type text JavaScript. First thing I'll do within this JavaScript is create a variable to hold a reference to the XHR object. And I'll set that equal to null initially. This isn't absolutely necessary, but you may want to consider doing this, particularly as your pages get more and more complex with more JavaScript. I may use that XML HTTP request object repeatedly within the page, and so I probably just want to create it once, have it done with, and then have it available for the entire page. Not necessary, but one way to do things. All right, the next thing I'm going to do is create that getLocations function. I'm going to provide a place for the response that we're going to get back from the server. And then I'm going to check to see, first of all, if that XML HTTP object is currently null. All right, if it is null, I'm going to call a separate init XML HTTP method. Doesn't exist yet, but I'll create that shortly. And that'll take care of the dirty work of instantiating that object, because we're going to do a little bit of work within the sample in order to make this relatively cross-browser, so that you can run this code in various browsers, and there's a pretty good chance that it'll work. All right, so let's flesh out getLocations first. So once XML HTTP holds a reference to the XML HTTP request object, I need to come in and execute the open method. And this is going to essentially open a channel or set up the XML HTTP request object in order to communicate with the server. I'm going to use a GET request. That's an HTTP GET. And it's going to go out and get the statelist.htm file. This could also be a full URL, it could be a relative path, and so forth. But keep in mind that this is making a request from the browser to the server. So whatever form I provide here, the server is going to need to be able to find that file. And in this case, I'm going to make a synchronous call. Most of the time, AJAX is asynchronous, which doesn't block the code executing within the browser. But I'm just going to keep this real simple so I don't have to implement any callback functions. All right, so that sets up the XML HTTP request object to make this request. And then I need to send it. I'll do an XML HTTP.send, and I'll pass in a null because I don't need to pass in any additional content. But if the request required any other kind of content, any parameters and so forth, I could send them as part of that send method. So when this statement executes, it's going to execute a blocking or synchronous call to the server and sit there and wait for a response. So once we get a response, I need to find out what that response is, get the content that I received back from the server. So I'm going to create a content variable and use the response text property in order to get that response. And then the other thing I need to do is get a reference to the location where I'm going to update this information on the page. And so I'll create a locations variable, and I'll use the DOM, or the document object model, in order to get a reference to that div tag that I added to the page. So the standard or most common way of doing this is using the document model. Notice that now I'm getting complete IntelliSense, even though I'm not writing C# or Visual Basic code on the server. Document.getElementById, and I need to pass in the name of that div tag and its locations. All right, so at this point, I have the content, I have a reference to the location, so I just need to now dynamically update the page. So as a check, I check to make sure that content and locations exist. And if so, I'm going to update that locations and set the inner HTML property to that content. Because remember, that stateless page is going to return to the client browser some well-formed HTML code. All right, so that's the getLocations function that executes when the user clicks on that button. There's one other piece of code that we need to create, which is init XML HTTP. There are a lot of different ways of implementing this kind of code, but the idea is that the code needs to be as robust as possible and to try and return a valid XML HTTP request object from as many browser configurations as possible, since every browser provides an XHR object a little bit differently. Fortunately, modern versions of browsers are starting to become more standardized, so it's becoming less of a problem, but we still haven't fully solved that problem. So what we're going to do now is create one version, but it's not completely robust. All right, let's go down here and create another function and call it init XML HTTP. And it's going to be a series of try blocks. So I'm first of all going to try to create the XML HTTP object directly using that module level variable right there, and new up an XML HTTP request. As you saw, it's available within IntelliSense, so Microsoft is now supporting this version of the notation in order to get a reference to the object. And if I get it, I'm going to go ahead and return. I'll have a little catch block here because I want to ignore the error. Because if that doesn't work, if that raises an exception because this code is running within a browser that doesn't implement XML HTTP requests like this, I'm going to go on to the next step. And in this case, it probably means that I'm using an earlier version of Internet Explorer, so I need to instantiate an ActiveX object. So I'll do another try block. And again, attempt to set the XML HTTP object equal, in this case, to a new ActiveX object. And one of the options is msxml2.xml http.4.0. And I'll again return if that occurs successfully, and include a catch block. And I'll just go ahead and copy this line of code. All right, and I'll add one more variation. Older versions of Internet Explorer might use a form that looks like this. Just XML HTTP. All right, there's lots of other variations, but this is a reasonable sample for our purposes. But if we get through this and we don't get a reference to the XML HTTP object, we're just going to explicitly set it equals to null. And then we can do any kind of error handling, whatever is necessary to handle the situation where we can't get a reference to that. We would need to degrade gracefully somehow. All right, so I'll save the page, and I'll right-click on it and view in the browser. There we have our Get Locations button, and I'll click on it, and now we made an AJAX type request to the server. In fact, let me click on it again. Notice that the page is not refreshing. If I refresh the page, you can see that it flashes a bit, the old data goes away, and for a brief moment, we had that status bar appear at the bottom of the page. So I'll refresh it one more time. Okay, so that's a full page postback. But again, notice if I click the button here, it's making a request through JavaScript, which is not a full page postback. And the browser doesn't flash, and the data appears. Now, obviously, I'm running this page going against the server that's on the same machine, so it's very fast. If this was a public internet site, and you made a request from a client browser, there might be a little bit of a lag time of a second or two, depending upon the speed of the network and the responsiveness of the server. Now, this is a simple example, but it's actually very, very powerful. Because the ability to communicate with the server on a web page without requesting the entire page again is the fundamental process that drives AJAX development. And the communication is the important event. When the response from the server is custom data from a database, or maybe custom JSON objects, you have endless opportunities to build features for the user page and just update a portion of the page rather than updating the entire page with a full page postback. Now, ASP.NET doesn't just support client-side AJAX like you just saw. It also provides features that can enhance web forms to support what are called partial page postbacks. By wrapping a portion of a web forms page with special AJAX server-side controls, you can add AJAX features to an existing page with very little effort. Now, the major change that partial page postbacks bring to an application is the way in which the server processes requests from a client browser. In relatively broad terms, you now have two options. You can use traditional full page processing or AJAX partial page processing. The browser is always going to make a full page request to initially load the page. And then the user can take actions on the page that either cause a full page postback or an AJAX request. This means that you can continue to regenerate the full page when user actions require a lot of changes, or just update a small portion of it when that's appropriate. Let's talk a little bit more now about traditional ASP.NET page processing. ASP.NET web forms use the traditional ASP.NET method of processing a page request or postback. And this is generally how that works. So the user begins by loading a page, such as by typing in www.appdev.com in the address bar of a web browser. That action causes the AppDev web server to build the home page and return the full page to the client browser. The user can then peruse the page, looking at courses and so forth, and then clicks a link that either causes a postback to the same page or requests an entirely different page on the app dev site, or conceivably clicks on a link that takes the user to an entirely different site. In any case, the web server builds the entire requested page and then sends it over the network back down to the browser. In the case of a postback, there may be some sort of state information that's sent along with the request and the response as well, which can alter the resulting page that's returned to the browser. And it's important to understand that behind this process is a set of page events, handlers, and so forth. There's a number of things that are triggered when you make a request for an ASP.NET page. There's a lot of processing that occurs in order to dynamically create those pages. So now let's contrast this with ASP.NET AJAX processing. After the initial page loads, when the user clicks a link or takes some other action that causes an AJAX request, the server is not going to regenerate the entire full page. Instead, what it's going to do is it's going to hit the web server, hit the same basic processing engine, and is going to generate a small portion of the page. So the browser is making a request for a specific piece of information, what actually is implemented as a set of XML, a subset of the full page. And then on the client, on the browser, JavaScript will update a portion of the page. The result is that only a small portion of the page updates, and you don't have the flash of the entire page. Now, it's very important to note on this diagram that you still have various page events, handlers, and so forth occurring. This is unlike a pure client-side AJAX request, in which you're just making a request for a little piece of data. When you make a partial page update using the ASP.NET AJAX features, you're actually passing to the server the full set of view state that you would normally pass with a full page postback. And when the server generates and returns the response, it returns that view state data back with the request. So this is not very lightweight. There's still a lot of processing on the server, and there can be a huge amount of data that's being transmitted with each request and response. So you have to be careful. So in this course, we'll be covering both server-side and client-side AJAX, and you'll see the differences between the two. So let's talk a little bit more about this ASP.NET AJAX processing. The browser and the server process the AJAX request quite differently from a traditional page request. With AJAX, the request doesn't occur through a normal full page postback using post or get or so forth, as it does for traditional page postback. Instead, the request occurs using client-side JavaScript, along with perhaps the Microsoft AJAX library that supports this kind of programming, that the server sends to the browser with the initial load of an AJAX-enabled web page. To some extent, this bypasses normal page processing. And there's generally how it occurs. So you have a client browser, has JavaScript enabled, is using some sort of client framework, and makes a request to the web server. And the web server will process the request. The steps that the web server is going to take in order to process that request depends upon whether or not you're using a partial page postback or a pure client-side AJAX request. Now, the XML HTTP request object is an API that JavaScript is able to use to make asynchronous calls between a browser and a server to pass XML or usually other text formats. It's a direct communication from JavaScript to the server and bypasses the normal full-page process in the web browser. And because the communication is asynchronous, JavaScript and any client libraries process the data that the server returns whenever it arrives, so the browser remains responsive to the user in the meantime. Microsoft originally introduced ASP.NET AJAX as an add-on to Visual Studio 2005 and ASP.NET 2.0. They released it after the release of 2005 and ASP.NET 2.0, so it required a separate download and installation. And it also meant that some features weren't fully implemented in the Visual Studio development environment. And they really still aren't 100%, But with each new version of Visual Studio, Microsoft has improved the integration with AJAX. But then, in Visual Studio 2008 and ASP.NET 3.5, Microsoft built AJAX into the framework and the tools, the Visual Studio tools, so that every ASP.NET application that you develop has all the controls and libraries necessary for both server and client-side AJAX. And then, in Visual Studio 2010 and ASP.NET 4.0, those tools made the AJAX framework even more tightly bound to the development environment and framework, so that using AJAX is now nearly seamless. One of the ways that Microsoft has made using these technologies far easier is that they've enhanced with every new version of Visual Studio the support for JavaScript debugging. In earlier versions, Visual Studio had very limited ability to debug JavaScript. In fact, you had to kind of jump through some hoops and run some code, and then you could do some breakpoints sort of, and you had to go into these cryptic files, and it was just really hard to make work. But now it's just about as easy to debug client-side JavaScript code as it's long been to debug server-side code. And the debugger includes the ability to set breakpoints, examine variable values, and do a lot more. A lot of the same things that you're probably used to if you're debugging C# and VB code. So this puts AJAX development, particularly on the client side, within reach of all web developers. So Visual Studio 2010 has great support for debugging JavaScript. But to really understand and debug AJAX code, you need to understand the interactions between the client and the server. And those interactions are bundled as HTTP request and response packets using the HTTP protocol, relatively low-level protocol. And this is one of the few areas that the Visual Studio debugger really doesn't expose to you. One of the best tools that we found for this purpose, short of spending insane amounts of money, is an unsupported tool from Microsoft called Fiddler. Fiddler is a web debugging proxy that captures all of the HTTP and HTTPS traffic for SSL encrypted traffic between your web browser and server. You can inspect the traffic, the request and response objects. You can set breakpoints and create your own HTTP requests. And you can use it with any browser, but it really is most closely integrated with Internet Explorer. And you can go to www.fiddler2.com to get more information and download the tool. Another useful tool is Firebug, which is an add-in for Mozilla's Firefox web browser. Firebug has a lot of features that let you explore the JavaScript code that executes within the browser and its interactions with page elements. In fact, it does a lot of the same things that now finally Internet Explorer 8 and later have support for. One of the best features is the XML HTTP request spy. This is handy when you write client-side AJAX code because the tool provides rich information about errors that occur. In fact, many otherwise very loyal Microsoft developers use Firefox as their default development browser just because of this great usefulness of Firebug. So you can get more information about Firebug at getfirebug.com, or you can use the Get Add-ons button within Firefox. What we're going to do now is see AJAX in action and see how full and partial page postbacks compare. I have two sample pages here, Time and Time AJAX. So I'll go ahead and run this page just so you can see what it does. And I'll view it in the browser. So a very simple page, some static text, and a button that I can click in order to get the time that I last posted back to the server. So this causes a full post back to the server. As you can see, every time I click it, it flashes. The easiest way in Internet Explorer to see that is watch this little status bar down here. So it's causing a full page post back. So every time I click this, it's making a new request for that page, and the server is having to make a request for that full page, generate that full page, and send it back down to the browser. Obviously not a major deal for this relatively simple page, but if it was a more complex page, it might take a fair amount of time for the server to generate that page. So let's take a look at the code that implements this page. As you can see, it's a fairly straightforward page. I have all the usual header stuff up here, style sheet to make it look pretty, some static text. Here's the label that's going to contain the time after I click the button, and a little bit of initial text. Here's a button. The ID is postback button. It's going to run at server. It's a server-side control. And when I click it, it's going to execute the postback button _ click event procedure. And we can take a look at that code. As you can see, all it's doing is providing some static text and then reading the current time using the datetime object, and then assigning that string to the text property of that time label. Again, very simple, very customary sorts of ASP.NET web forms sort of coding. All right, I'm going to go ahead and run the page one more time. And I'll click on the button and then look at the page source. So a lot of static text, just pretty much what you would expect. It's a web forms page, so it has this hidden view state element that has information about the current state of controls on the form. Very simple form, so view state is a relatively small amount of data. But if we had a list view or a data grid or some other kind of complex server control, this might be hundreds of thousands of bytes of data. It can really cause page bloat if you're not careful to manage view state. And then because we have a control on the form that responds to an event, we also get this event validation data. And this has more data that ASP.NET uses in order to determine whether or not to raise particular events on the server. What's interesting is that this is the string that was generated by that postback button _ click event procedure. It's contained within the page as a static string. Because we did a full page postback and the server regenerated this entire page and inserted that string as a literal string, there's no more programmatic or any kind of dynamic element to it when it's located within the browser. So that's just about as simple a dynamic page as you can write with a web forms application. All right, so let's take a look at the AJAX version of the page. I'll go ahead and run it first. And as you can see, it has two buttons this time. I still have the postback time button so that I can cause a full page postback. So notice each time I click that, I get a new time and the browser refreshes. There's also an AJAX version of the button that doesn't cause that kind of postback. Notice that each time that I click the button, it's not causing a flash to the browser. So let's see how this is implemented. A little bit more complex of a page. We still have the time label, that initial time. We still have the postback button, and it still causes the postback button _ click event procedure to run. So this part of the page hasn't changed. But now we've added this additional HTML code. We have a label called AJAX time label. It still runs at the server, and it has some initial text. And then we also have a button that fires a server-side event procedure. One of the major differences here is that we have a script manager control. This is required for all pages where you make use of partial page postbacks. And this manages, as you can imagine from the name, it manages the scripts that are required in order to implement these AJAX features. And then there's an update panel control. This contains the portion of the page that I want to update using AJAX. So I just have to wrap this and a content template around the portion of the page that I want to use AJAX to update. So there's quite a bit more HTML that you need to include in the page. But it's a little bit misleading because I really just need one update panel and I can wrap as much HTML as I want. I'm not limited to just single pairs of labels and buttons. We can look at the server-side code, and this is pretty much similar to the other example. I'm just generating a string that's using the the datetime object in order to get the time. And I'm doing that same thing in the click event procedure of the AJAX button as well. So notice that there's really nothing special about this code. It's just regular server-side code. All right, I'm going to go ahead and run the page again. Click the button a few times. Click this one a few times. And then look at the page source. Just scrolling up and down, you can immediately see that there's a lot more stuff in this page. We have some additional hidden fields, but we also have some JavaScript. As soon as I add the Script Manager control to the page, it adds some JavaScript. And then, because I'm using an update panel, there's some additional JavaScript that is required. And that's mostly contained right here. But as you can see, we have some web resources, some script resources. This is some of the dynamic JavaScript that ASP.NET generated in order to make this custom page have that partial page postback feature. So that's a lot more page source than you saw within the time.aspx page. So most of this additional clutter is the JavaScript that's required to activate the page on the client side. And some of it's dynamic, and some of it is static. And then other code takes care of the various events. In this case, to process the button click. And still other code takes care of initializing the client-side AJAX library.